Assalamualaikum warahmatullahi wabarakatuh. In this video, I will explain about 7 segment display. I will show you how to make a connection between microcontroller and the 7 segment. This video is for my class EPO361 Microcontroller Based System Chapter 5 Subtopic Input Output Technique, and I will explain about 7 segment display. So what is 7 segment display? This is 7 segment display. If you Google on the internet, you will find many website or web page explain in detail about 7 segment display. Okay, for example, this one, I like this page. This one is from rsonline.com. Why? Because it is simple, easy to understand, and it has all the information needed for you to program your 7 segment. Okay, so what is 7 segment actually? 7 segment, this is 7 segment. It is an electronic device used to display decimal numerals. Okay, it can be used to display number 0, number 1, number 2, number 3 up to number 9, and sometimes you can use to display number hexadecimal number. Okay, for example, A, B, C, D, E, and F. It is widely used in digital clock, electronic meter, or basic calculator. Again, if you Google on the internet, you will find many applications of 7 segment. Okay, this one is a digital wave scale. Okay, as you can see here, the 7 segment is used to display the weight of the items. And this one, in this example, 7 segment is used as a timer for the traffic light system. And this one, 7 segment is used for digital clock. And this one is a calculator. So what does it consist of? A 7 segment consists of 8 LEDs. Okay, basically a 7 segment is a combination of 8 LED, 1, 2, 3, 4, 5, 6, 7 and 8 connected in parallel that can be lit in different combination to display the number. Each segment is denoted by letter A to G. This one is segment A, segment B, segment C, D, E, F, G and decimal point. Okay, there are two types of configuration for 7 segment. The first one is common anode configuration, and the second one is common cathode configuration. What is the difference between these two configuration? For common anode configuration, this one is common anode, this one is common cathode. For common anode configuration, all the anode pin of the LED are connected together and become a common pin. Okay, all the cathode pin of the LED are supposed to be connected to the microcontroller. Okay, for common cathode 7 segment, all cathode pin are connected together and become a common pin, and the anode pin of the LED are supposed to be connected to microcontroller. Okay, this is the pin out of the 7 segment. This one is common pin. There are 2 common pin, you can use either one. This is for segment A pin, segment B, decimal point, C, D, E, F and G. For common anode configuration, the common pin of the 7 segment here is supposed to be connected to positive power supply or VCC. And for common cathode configuration, the common pin is supposed to be connected to the ground. Now, how are we going to program the 7 segment to display any number? I have prepared this table to help you understand how to generate hex value for any number you want to display on 7 segment. Okay, this hex value will be used in your C programming code later. Okay, let's say I want to use common anode configuration and I want to display number 0. So use your imagination how number 0 looks like on your digital calculator. Okay, I suppose this is number 0. All the segment supposed to be turned on except segment G and segment decimal point DP. Okay, for common anode configuration, if we refer back, the common pin is supposed to be connected to positive power supply. Therefore, to turn on any segment, we have to set logic 0 here. So segment A supposed to be turned on, so we must set 0. B0, C0, D0, E0, F0, and G supposed to be off, we set it 1. And decimal point also 1. So this is binary number. If we code it into BCD, we get this one is 1100 is C, and this one 000 is 0. So this is the hex value to display number 0 on common anode configuration. Okay, let's say I want to display number 1. This is number 1. So only segment only segment B and C turn on. B and C 0. The rest is 1. So if we code it into BCD, this one is F and this one is 9. So I've shown you 2 examples on how to find hex value for 2 decimal number 0 and number 1. So I left the rest blank box here for you to find the hex value by yourself. Okay, the most important part in this table is this hex value. Why? Because later this hex value will be used in your programming. So if you get the hex value wrong, the 7 segment might display unrecognized symbol. So make sure you get it right. This one. Okay, once you completed this table, you get all the hex value for all decimal number here. We can go to the next step, which is programming part. Okay, but before we can start our programming, we have to create a simple schematic for 7 segment. Okay, now let's find 7 segment library in Proteus. First, we just enter segment here, and then choose optoelectronic, and then 7 segment display. We have many options here, but I'm going to choose this one because this one is CA, stand for common anode. CC stand for common cathode. So we will use common anode in this example. Alright, now I will zoom in. You can press Ctrl F1 so you get a smaller grid, easier for you to make the connection. Okay, this one for segment A, and this one for segment B, this one for segment C, segment D, segment E, segment F, G, and decimal point. Okay, this one is common pin. Since this is a common anode 7 segment, the common pin should be connected to power supply. Therefore, I will select power supply and make the connection here. Okay, that's it. We're done. Now let's get to the programming part. Just create a new project. Okay, give your project name any name. For example, PIC7 segment. Select your project folder. Select your device name. And for device clock, I will put 20 MHz. Just click next. Save your project. Yes, next, and finish. Okay. First of all, I will put infinite loop control structure. I'm going to use while. Okay, open bracket and close the bracket. it is a good practice if you can put an infinite loop control structure inside any microprocessor or any microcontroller program. Why? Because we don't want the CPU to hang or stop or idle somehow. Okay, we want the CPU to execute our program line by line again and again non-stop. Okay, first we need to configure port. In this example, the 7 segment is connected to port B and 7 segment is an output component. Therefore, port B should be configured as output. In programming, we can configure port B as output by setting trace B. Okay, set trace B as output. Alright, now I want to display number 0 on the 7 segment. So in this example, I should send some hexadecimal value to the port B. Port B send hexa value. Let's refer back to our table here. To display number 0, okay, I must send C0 to port B. To display number 1, I must send F9 to port B. So to display number 0, I must send C0 to the port B. Okay, let's see what happened. Build the project. Okay, save the file first. Okay, no problem. And now we should load the hex file into microcontroller. Just double click and then select your program file, 7 segment, PIC7 segment. Alright, okay, now run the program. Okay, as you can see here, number 0 is displayed on the 7 segment. Okay, now I want to display number 1. To display number 1, F9 should be sent to the port B. So just change the hexadecimal value here, F9, and then rebuild your program, stop the simulation and rerun the simulation. See, okay, number 1 is displayed on the 7 segment. Let's do something more. I want to display both number 0 and number 1. Okay, I will add some delay here, about 1 millisecond, about 1 second. Okay, first I want to display number 0. Number 0 is C0 in hexa, and this one is for number 1. Let's see what happened. Alright, stop the simulation and run the simulation. Okay, number 0 display on the 7 segment. After 1 second, number 1 is displayed, and the process keep repeating itself because of the infinite loop control structure here. 0 1 0 1. Okay, okay, as for the exercise, I want you to create a simulation similar to this one. It will display counting up number from 0 up to 9 and then A, B, C, D, E and F. Okay, and I will give you some hint. First, what you need to do is you have to fill all the blank box here and use the hex value here into your programming code. Okay, so good luck. Okay, for next example, I will show you the alternative, how to connect the 7 segment to the microcontroller. In this example, I mean this circuit, the 7 segment is connected to the microcontroller through port B. There are 8 wires here, and this might give a problem if your project consists of multiple 7 segment. You might have not enough input-output port at the microcontroller side. Therefore, to reduce the number of wire here, I will introduce to you a device called 7447. this is a 7-segment decoder or 7-segment driver. 7447 is for common anode and 7448 is for common cathode. So I'm going to use 7447 since in this example I'm using common anode. Now let's modify this circuit and find 7447 in the library. Okay, QA for segment A, QB for segment B, segment C, segment D, segment E, segment F, and finally segment G. The decimal point is left unconnected. For common pin, we should connect to power supply. Okay, for the input part, A should be connected to LSB RB0, B RB1, C RB2, C to RB2, and D for RB3. For BI, RBO, RBI, and lamp test pin, we should connect to VCC. So put some power here, just connect. This one goes here and this one goes here. Okay, in this example I'm using 7447 to drive the common anode 7-segment. Now let's go to the programming part. Just create a new project, PIC_7-segment 7447. Everything else still the same, and just put 20 megahertz here. Just click yes, next, and finish. Now first thing we have to do is create infinite loop inside our main program. Y1. Okay, then we need to configure port B, set as output. Okay, let's say I want to display number 0. I have to send hexadecimal number to port B. Just send 0. Let's see what happened. Okay, save the file first, and then reload this file here, 7447. Okay, number 0 is displayed on the 7-segment. If I want to change the display here, just change the hexa value here to, let's say I want to display number 2. Okay, what will happen? Number 2 is displayed on the 7-segment. Okay, so I want to display number 7. So it's easier than the previous example, because you just need to change the last digit here to display on the 7-segment. The problem is it can only be used to display number from 0 to 9. You cannot use 7447 to display A, B, C, D, E, and F. Okay, only number. Okay guys, that's all for my video, and in my next video I will show you a demonstration on 2-digit counter simulation using 7447 and common anode 7-segment. If you like my video, don't forget to subscribe, like, and share. Thanks guys.